Lesson 8.8, Solving Rational Equations. Solving a rational equation can involve the procedures from several other concepts that we've worked on in the course. We have adding, subtracting, multiplying, dividing, and simplifying rational expressions, and solving proportions. The steps are as follows. First, we simplify each side of the equation. That means we'll add, subtract, multiply, or divide the terms to obtain a single term on either side of the equal. Then we must identify the excluded values. These are the values that x cannot equal, or they'll give a denominator of 0. We cross-multiply the proportion, and then we solve the resulting equation. So here we have some examples. These are some simple rational expressions in that we have monomials as our denominators. 1 over 6k squared is already simplified, so that will stay exactly as it is. But now I have 1 over 3k squared and 1 minus k. I need to give these a common denominator so that I can combine like terms. In order to turn a k into a 3k squared, I can multiply it by 3 and k. So if I multiply both the numerator and the denominator by 3k, I'll have 1 over 3k squared minus 3k over 3k squared. Now I need to combine this. So I'll have 1 over 6k squared is equal to 1 minus 3k over 3k squared. Now I have a proportion. A proportion is when you have two fractions equal to each other. And in order to solve a proportion, we must cross-multiply. So I will multiply this way and this way. When I multiply 1 times 3k squared, I get 3k squared. Then I have an equal, so one multiplication equals the other multiplication. And the other multiplication is 6k squared times 1 minus 3k. I'll distribute my 6k squared. So 6k squared times 1 and 6k squared times negative 3k. This will give me 3k squared minus 6k, or equals, 6k squared minus 18k to the third. Now, in order to solve this, I'm going to need to bring all of my k's to one side and set this equation equal to 0. So I'm actually going to move these two over to the other side. And since 6k squared was positive here, it'll be negative here. And since 18k to the third was negative, it will be positive. And I set that equal to 0. Combine like terms. 3k squared minus 6k squared is negative 3k squared. And now when I solve this, I can factor a 3 and a k squared from each of these terms. 18 divided by 3 is 6. I had 3 k's. I took 2 away, so I have 1 k left. And then 3 divided by 3 is 1. I had 2 k's and I took 2 away, so I have none left. Then I set each of these factors equal to 0. Okay. 3k squared equals 0, so that means k squared equals 0, so that means k equals 0. Here, 6k minus 1 equals 0, so that means 6k is equal to 1. So k is equal to 1 over 6. Now, we need to double check our excluded values. And these are the values that k cannot equal. I have 6k squared and 3k squared in the denominators. So I set each of those equal to 0. If 6k squared equals 0, that would mean k equals 0. If 3k squared equals 0, that also means that k equals 0. So this is what k cannot equal. Right here. That tells me k cannot equal 0. So that tells me that this is not a valid result. So my solution to this equation is k is equal to 1/6. Because if I plug in a 0, I get 0 in the denominators, and 0 in the denominators results in an undefined fraction. Okay, let's look at our next example. I have 1 over n squared plus 1 over n is equal to 1 over 2n squared. I need to make these denominators match. In order to do that, I want to turn this n into an n squared. So I multiply by n to the numerator and the denominator. That gives me 1 over n squared plus n over n squared is equal to 1 over 2n squared. Sorry. I'll add these together, so I'll get 1 plus n over n squared is equal to 1 over 2n squared. I cross multiply. N squared times 1 is n squared. And then I have 2n squared times 1 plus n, which I need to distribute. And that gives me 2n squared plus 2n to the third. Putting everything on the same side, I can do a different approach here. I can subtract n squared from both sides. And I'll get 0 is equal to n squared plus 2n to the third. Now I'll factor out an n squared, and that will leave me with 1 plus 2n. If I set each of these equal to 0, I can solve for the possible values of n. If n squared is 0, that means n equals 0. 1 plus 2n equals 0, that means that 2n is equal to negative 1 if you subtract 1 from both sides. And dividing by 2 gives me n is equal to negative 1/2. And now I need to see which are my excluded values. I have n squared and 2n squared. That all results in n equaling 0 if I set each of them equal to 0. So this is what n cannot equal. So that means that this solution is invalid. So my solution is n equals negative 1/2. Let's try a couple more. This one gets a little bit further complicated. So the first thing I'm going to do is I'm going to factor this denominator and pull out a v so that I can see what I need to do to make these denominators match. I need to multiply this times v minus 5. So I'll multiply my numerator and my denominator times v minus 5. So 1 times v minus 5 is v minus 5, and that's over v minus 5 times v plus 3v plus 12 over v times v minus 5 is equal to 7v minus 56 over v squared minus 5v. I'm going to add these together. V and 3v is 4v. Negative 5 and 12 is 7. Now, if I multiply these back, I'm going to get v squared minus 5v. And I'm going to go ahead and do that, and I'll show you why in just 1 second. I have my proportions, so I'm going to need to cross multiply. This will give me 4v plus 7 times v squared minus 5v is equal to 7v minus 56 times v squared minus 5v. Now, rather than multiplying all of this out, because I have multiplication, sorry, those should have parentheses around them, because I have multiplication here, if I divide both sides by v squared minus 5, watch what happens. As we learned from simplifying rational expressions, these will cancel. And I'll be left with 4v plus 7 is equal to 7v minus 56. I can subtract 4v from both sides or 7v from both sides. It doesn't really matter which. And that will leave me with 7 is equal to 3v minus 56. I will add 56 to both sides. And that will give me 63 is equal to 3v. And dividing both sides by 3, I'm going to get v is equal to 21. Now I need to make sure that that is going to be a valid result, and so we need to set this denominator equal to 0. And I would get that v equals 0 or v minus 5 equals 0. So that would mean that v cannot equal 0 or 5. Well, I got that v was 21, so this is okay. This is valid. Okay, here I have m squared minus n and m. M squared minus m factors to m times m minus 1. So I need to multiply this solo m times m minus 1, and my numerator times m minus 1. And when I multiply 1 times m minus 1, I just get m minus 1. 1 plus m minus 1 is just m. If I were to cross multiply, I'll get m times m squared minus m is equal to 5 times m squared minus m. That's for my cross multiplication. Dividing both sides by m squared minus m gives me that m is equal to 5. Now to check my excluded values, I would set m squared minus m equal to 0. That would give me m times m minus 1 equals to 0. So m would be 0 or m would be positive 1. So this is what m cannot equal. And since 5 is neither a 0 nor a 1, this is a valid solution. Okay. When I have a whole number, then I just make my denominators match by putting it over itself. If it's 1, if it's a 2 or a 3, so just as an example, if I needed to turn a 2, I would do 2 times n minus 8 over n minus 8. But since it's just a 1, I'll have just n minus 8 over 7 over n minus 8. I have to distribute that negative. So I'm going to have 1 minus n plus 8 over n minus 8 is equal to 7 over n minus 8. That gives me negative n plus 9 over n minus 8 is equal to 7 over n minus 8. Cross multiply, and you'll have negative n plus 9 times n minus 8 is equal to 7 times n minus 8. Dividing both sides by n minus 8 will cancel those out. So I have negative n plus 9 is equal to 7. Subtract 9 from both sides, and you get negative n is equal to negative 2, which gives me n equals 2. But I need to check my excluded values, and I need to set n minus 8 equals to 0. And that would give me n equals 8, so n cannot equal 8. We got that n equals 2, so this is a valid solution. Now number 10 here is going to take a bit more work. I'm going to have to factor this in order to find my common denominator. I'm looking for factors of positive 10 that will give me a negative 7. So I'm looking for two negative factors. 2 and 5 are both negative. Negative 2 times negative 5, multiply to make a positive 10 and add to make a -7. So in order to make this denominator match, I'm going to need to multiply both sides by, or the numerator and the denominator, by r minus 5. So I'll get r minus 5 plus 1 over r minus 5 times r minus 2 is equal to 6 over r minus 2. Collecting my like terms, I'll get r minus 4 over r minus 5 times r minus 2 is equal to 6 over r minus 2. I'll cross multiply r minus 4 times r minus 2 is equal to 6 times r minus 5 times r minus 2. And since I have r minus 2's on both sides, if I divide both sides by those, they'll cancel. So I'll get r minus 4 is equal to 6 times r minus 5. Distribute your 6. R minus 4 is equal to 6r minus 30. I'm going to subtract r from both sides, and I'll get -4 is equal to 5r minus 30. I'll add 30 to both sides, and I will get 26 is equal to 5r. Divide both sides by 5 to get r is equal to 26/5. Now I need to double check myself and make sure that this is a valid answer, and I look at my denominators. I have an r minus 5 and an r minus 2. This tells me that r cannot equal positive 5 or positive 2. Since I have 26/5, I'm okay. Why don't you go ahead and try 19 and 20. Remember to factor first, then common denominator, then simplify each side, then cross multiply and solve. So once you're finished working the problems out, 19 and 20, unpause the video and come back and see how you've done. Okay, now that you've had a chance to work these problems out, let's check your work. You should have gotten the results that p is equal to 4 and that n is equal to -4, with the excluded values of 0 and 1 for p and 0 and -5 for n. If you need to take a moment just to pause the video and look over the work, all the steps are here, and you can check your work that way.